let's do some magnetism. Some people had questions on magnetism. Let's find out what this is all about. And people ask these questions. Says, how do magnets attract each other? Good question. That is a good question. Someone says it's magic. Another fellow says, you have not explained it either. Well, I haven't explained it. I explained it many times. The mechanism. Okay, the cause, the physical mechanism, right? And he says, then he says something about experiments, and that they've done a lot of experiments. Yeah, they do experiments. Here's an experiment. Look, that's an experiment. Watch, observe. Okay, watch carefully and make predictions if you want. Right? Here's it. 2 magnets. Right? Those 2 dark holes there. There it is. Okay, it attracts. Right? And there's another. I don't have another one here. I guess I'll have to get one next time. But anyways, you have. If I turn it around, it pushes them away. Okay, fine. So we've all experienced that. So that's the only experiment you need. You don't need any other experiment. Now you need to explain what's happening here. Okay, and one thing I'm going to tell you is nothing is pushing my hands. I can feel that it's not pushing. Something's pulling these things out of my hand. It's already, pulling from the inside. So there's a pull force in there. Okay, there's a pull force. There's a tug. There's an attraction. Okay, it's not a push. Okay, and people say, well, we'll do a Casimir effect. You remove all the stuff from here, and whatever's on the outside pushes my 2 hands together. That's not the case. You don't feel any push from the outside. It's in fact, maybe I can hold it like this. You can see. Yeah, it already attracts it. It already takes it inward. Okay, and again, there's a pull inside there. You got to explain that pull. And these people, some of them say that they already know it. That's been proven and taught to them in high school. Here's one fellow. He says the following. He says how magnets work. That's something we usually learn in school. Oh, I didn't learn it. Maybe you went to a different school, maybe a different monastery, I guess. It's pretty much factual. Okay, no need to think about something that has been proven. They look for proof, right? Daily over 1 million times. Okay? Yeah, and this is the issue. The issue is that these people talk about proof and they talk about a description. They say, yeah, positive attracts negative. North attracts south. There's your explanation. That's not an explanation. And this is the problem. The problem, these people don't understand what a mechanism is. They don't understand what an explanation is. They take descriptions for explanations. And they walk away and they say, oh, I understand. And you have north attracts south. Hey, that's so easy. And this is the problem. They have no mechanism, but they think they did. And that's why all these mathematicians can bamboozle them, and tell them whatever they want. Okay. Here's another fellow says, there are literally thousands of experiments you can do with magnets, and they know exactly what is in that region. No, they don't. That's the point. In fact, since the days of Faraday says, those lines of force, those are real. There's something in there. And Maxwell also said, there's some exotic matter in motion, as he said, in there. There's matter in there. And people say, well, I don't see anything. I don't see anything between the magnets. I don't see anything in there, so there's nothing there. Yeah, there is something there because something is pulling. And you can see that when you put the magnets underwater, and I've shown that in the past, where you can see, one iron filing is pulled into the magnet one at a time. Gradually you can see, because they do it in slow motion, and you can see all these iron filings slowly approach the magnet. So something is swirling in that region and picking up one iron filing at a time and pulling it towards the magnet. That's what's happening. There is matter in motion around a magnet. You can't see it, you can't touch it. There is something there. Okay? A field is not an object. Field is a region where all this activity is going on. That's what a field is. So you can't use the word field in science. Okay? It's an irrational term because all you're saying, a region. There's a region there. Yeah, there's a region. Regions don't do anything. You have to put something in the region for something to happen. And people don't understand that. Field is a mathematical concept that means region, a region where you have a bunch of values, where the strength of the field, or the force or whatever, is stronger or weaker. That's all a field is. But you can't use the word field as a battering ram, as a thing. Field is not a thing. Something is inside the region called field. Okay, so let's understand the wording here. Okay, so they asked a question from to a fellow named Richard Feynman. Some of you know him. And good old Rich, he had no clue whatsoever. He had no clue whatsoever how a magnet works. And so let's first go with the question. Here's the question they asked him. Listen carefully, okay? Here's what they asked. Good old Rich Dickie Feynman. Here it goes.
If you get hold of two magnets and you push them, you can feel this pushing between them. Turn it around the other way and they slam together. What I want to know is what's going on. Why are they doing that, or how are they doing it?
But the problem that you're asking, you see, when you ask why something happens, how does a person answer why something happens?
Okay, so they ask him the question, how does a magnet work? And he said, let me find out. He starts squirming because he doesn't know the answer. Okay, so this is what the first thing we have to settle is that Dick Feynman, he's a Nobel Prize winner, by the way, and he had no clue about the difference between a cause and a reason. And here you can see him. That's very important to point out because shows that, this fellow never learned anything. And he's a Nobel Prize winner. So here goes. Listen to him. There he goes. And listen to his arguments.
For example, Aunt Minnie is in a hospital. Why? Because she went out and she slipped on the ice and broke her hip. But it wouldn't satisfy someone who came from another planet, knew nothing about things. First you should understand why, when you break your hip, do you go to the hospital? How do you get to the hospital when the hip was broken? Well, because her husband, seeing that she had the hip was broken, called the hospital up and sent somebody to get her. You're perpetually asking why. Why did the husband call up the hospital? Because husband is interested in his wife's welfare. If you try to follow anything up, you go deeper and deeper in various directions. I'm not answering your question, but I'm telling you how difficult a why question is.
Okay, so if Richard Feynman, who had a Nobel, did not understand the difference between a cause and a reason, he's talking about reasons here, why they took his aunt to the hospital, that's got nothing to do with physics. He's using the wrong example. Obviously, he never learned that there's a difference between causes and reasons. But this is the key point here. He had no idea how a magnet works. And again, let's hear it from the horse's mouth. Here it is.
All I can say is that there's a magnetic force that makes them repel. When you turn them the other way, they attract. It has to do with the fact that in iron, all the electrons are spinning in the same direction. They all get lined up, and they magnify the effect of the force. Well, I've just have to tell you, that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion or magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do. But I really can't do a good job, any job, of explaining magnetic force because I don't understand it.
So, can Richard Feynman explain how a magnet attracts another? Absolutely not. He has no clue whatsoever. Talks about electrons spinning. So what if they spin? If you have two magnets and they're spinning here and spinning here, right? The electrons. So how does that produce attraction? The fact that they're spinning, each one in its own magnet. So again, the fact that they spin doesn't tell us anything about the mechanism of attraction. And of course, the only way to figure that out is figuring out, making an assumption about what physical entities are in that region that we cannot see or touch. And there's no experiment you can run for that, no math. All you can do is make an assumption. You make an assumption about what could be in there, then you explain the mechanism. That's the way it works in physics. Okay, and just in case, here's the bot, okay, the AI bot, and they ask them the same question. When two magnets are brought close together, their magnetic fields interact. The north pole of one magnet will attract the north pole, the south pole of the other magnet. That's all it is. North attracts south. That's all they have. This attraction occurs because the magnetic field lines from north pole of one magnet enter the south pole of the other. So you have these field lines, which they say are inexistent, the lines of force, and so they enter. So what's entering? Field lines, which they say are just abstractions. So they have these field lines entering. Okay, so they enter. And how does that produce attraction? The fact that they enter, from one magnet to the other. Okay, and so they haven't explained by saying the field lines enter, or the electrons spin, or north attracts south. None of those are explanations. None of those are mechanisms. Okay, in summary, the attraction between magnets is a result of what? Their magnetic fields interacting. Fields cannot interact because fields are concepts. So you got to identify the object if you want to talk about, the mechanism of how two magnets come together. You cannot do it by saying fields interact. Fields are numbers, concepts. You can't say these numbers interacted. Okay? And the alignment of magnetic domains, again, the fact that they're aligned does not tell us anything about the mechanism of attraction. So what if they're aligned? How does the alignment produce attraction? That's what you got to explain. And they say, all these atoms are aligned within this magnet. Yeah, and so what? What does that tell us? Okay, so in order to understand some of this stuff, you need to find out what a mechanism is. A lot of these people don't even understand what a mechanism is. So they asked me for a mechanism. I showed them 100 times already, and they still, like this fellow said, you haven't explained it. I haven't explained it. I don't know what part you didn't understand. And so the problem is these people don't know what a mechanism is. They've been bombarded so much with concepts, with abstract mathematical idiotic concepts, never defined. And so they use these words. They use words like field and force and time and mass. And when you talk about objects, they say, what are you talking about? Again, half gun will travel. They don't understand what a gun is. They know what a mass is, but they don't understand what a gun is. You say, look, the guy shot him with a gun. What are you talking about? Oh, you mean a mass. He carried a mass. And the bullets, I guess, are tiny masses or what is it? Charges. So this is the problem. The problem, these people don't know how to talk. It's a semantic issue. They're trying to give a physical interpretation, and they bring in abstractions. That's where the problem is, okay? So they can't give you a physical interpretation, but they think they got one. They say, oh, I understood. What did you understand? That, an abstraction moved through the air? That's where the problem is. And so here, let's go easy on them. Let's go very slowly. This is a pulley. It's called a pulley, okay? And so what we want to explain, or someone asks, how is it that the box went up? That's the only question. Look how simple it is. A question of physics. Why or how, what caused the box to go up? Very simple thing. And so we say, look, there's a rope tied around this wheel. We call it a pulley. And we pull on the rope, and the box goes up. That's how you would explain it to a 5-year-old. You don't need to know weight. You don't need to know energy. You don't need to know mass. You don't need any of those terms, time, none of that force, nothing. All you need is to say, look, a rope pulled the box upwards. That's the explanation in physics. Okay, that's how you would explain it to a baby. And so they don't understand that because they start asking things like, you need to pull on the rope. Yeah, I pulled it with my hands. And what pulled on your hand? Well, it was my wrist. And what pulled on your wrist? Well, it was my elbow and then my shoulder. And so they always keep asking why this, why that. Questions that have nothing to do with the original question. The only question we want to answer is, why did the box go up? And it was pulled by a rope that went around a little wheel. That's why the box went up. That's where it stops. You got the mechanism. Now, the other guy now has to explain why the box went up if he's got a different theory. But that is the theory, for a pulley. And a lot of people don't understand that. Lots of people. And they get, especially devil's advocates. And so here we're going to explain the mechanism of attraction between two magnets. I'm going to explain the mechanism, okay? And you'll see what kind of questions these people ask you. They say, well, where did that come from? And, when were you born? And, they ask questions got nothing to do with the question we're trying to answer. So here it is, okay? This is the mechanism of how one magnet attracts another. We're just going to look at a mechanism and see if you can understand what a mechanism is, okay? And here it is, the one on the top, okay? We have two guys, axle and rod, and they're spinning their ropes. They're skipping, right? And as you can see, the rope of the blue guy, right, rod, goes up while the other one comes down. And when they meet, there's an attraction. It goes like this. There's a clamping there kind of thing, and constantly they're interfering with each other. So there's a pull there, okay? But if we turn rod around, right, the blue guy, you can see now the ropes are clashing. And now they're going to push each other away. So whereas in the first one, you have one coming up and clamping into the other one and pulling, on the second one, you have them clashing against each other and pushing each other away. That's a mechanism. It's called a mechanism. And these people say, well, where did you get the ropes? What are the ropes made out of? Irrelevant. I explained the mechanism. Okay? And all these people who use ether, that's what you got to do. Explain with your stupid ether, right? Show me with your ether a mechanism. I just want to see a mechanism. Don't explain it to me. Illustrate it, just like I illustrated there. I illustrated a mechanism. The mechanism of attraction, a mechanism of repulsion. It matches exactly what happens with two magnets. You put them, north to south, right? And they attract. And you put north to north or south to south, and they repel. There you have it. And for that, you have to turn it 180 degrees. And there you have it. Okay? So I showed you a mechanism that matches what we see with magnets. You show me now with your ether, with your space-time, with your energy, with your mass, whatever you want to use, charge, force, field, any word you want to put in there, I don't care. You got to illustrate it. We want to see a mechanism. We want to see a physical mechanism. We want to see a mediator in that region. I need to know what mediator you're going to put in there, physical mediator. It's got to have shape. We got to be able to see it. Then you can explain it in the background. But first of all, show us a picture of what you propose. That's the way it works in physics for physical interpretations. Okay, so there you have the mechanism. Okay, and here's the mechanism, a little more detail maybe. Yeah, okay. This is what we're saying. We're saying that two magnets are attracted to each other because you have these threads that go around. Okay, and the closer they are to each other, the two magnets, the more threads that intervene. And that's why there's an acceleration of one magnet towards another. We don't divide a magnet north and south. We divide it in top and bottom because the top goes counterclockwise to the one on the bottom, or vice versa, depending on how you have the magnet. Okay, so there's your north-south, and here are two magnets. That's why they attract, because these things are, you can see the threads that are swinging around. They more and more of them, as the magnets get closer to each other, they're swinging, they're interfering with each other. They're causing that clamping, okay? And if you put them the other way around, they push each other away. And here, let me show you that, okay? Again, to complete the mechanism. Here are the two mechanisms, okay? You have, what is this? North, south versus south, or north versus north. It doesn't really matter for repulsion. Here you have attraction, okay? Again, clamping, okay? You turn it around in this direction, nothing changes. There's still attraction. Why? Because you can see that nothing changed as far as the clockwise or counterclockwise direction of the threads. But when you put north against north or south against south, now they're clashing and pushing each other away. Look at it one more time. Here it is. Okay, this is the mechanism of attraction. Here it goes. We start with attraction. Here it is. Okay, one's going clockwise, the other one's going clockwise as well. They're both going clockwise, they're doing this. Okay, that way. Okay, so they're clamping, catching onto the other. Okay, and if you turn it sideways, no change. You will see the same clockwise and clockwise. But when you put clockwise against counterclockwise, that's when you have push. And, the bottom line on this is that Mother Nature does not understand positive, negative, does not understand North Pole, South Pole, doesn't understand any of that nonsense. What Mother Nature understands is clockwise and counterclockwise. That is physics. Okay. With that.